Okay, I actually lied. We're not done yet. There's one more thing I need to tell you about real-time shading methods because I'm actually traveling next week, so I'm going to have you do this part on your own rather than in class. So we just went over Gouraud shading, where we do a lighting model at each vertex of a mesh. And then I showed you how to incorporate Phong illumination into that, where we added specular reflections in addition to the Lambertian reflections. So what I'm going to show you now is a limitation of computing the lighting at each vertex and then doing the barycentric interpolation over the triangle. So if you look closely at the dyno, like if I zoom in a little bit, as I move around, you see the specular reflections look a little bit blocky. And so they change maybe in not so nice a way. And you can see how the interpolation is happening. I mean, if I show you the vertices that are in the mesh and the edges, you see that there's one vertex here and it's got its 6 neighboring vertices or 7 neighboring vertices. And so I'm only doing 7 lighting calculations here. And for all the points in between, I have to do a barycentric interpolation. So you can really see the effect. You must see like at the edges here of the mesh and the specular lighting. And that's really not so good. And I can also see it up here in the sphere as I move around. So if I'm only doing lighting calculations of the points, I also, especially if the specular reflection is kind of small, like it is here, it doesn't really take up much area. You can kind of see it jumping from one vertex to the next. So we would like it to be smoother. Oh, and also there's an even more major problem with the ground here. Actually, the ground mesh only has 4 points on it. So we're only doing 4 lighting calculations for the entire ground. And so we actually miss a really important effect, which is when the light is right above the ground here, we should be getting much more of a Lambertian reflection there. So one thing we can do instead is, rather than doing a lighting calculation completely at each vertex and then interpolating those colors throughout the triangles, we can instead interpolate the position, normal, and material color at each vertex throughout the entire triangle, and do the lighting calculations at each pixel. Okay? So rather than doing the lighting calculations in the vertex shader, I'm going to do the lighting calculations in the fragment shader. So I'm actually going to do a different lighting calculation for every pixel. And so to do that, I have to be able to interpolate normals throughout the triangles. So you can do that just with barycentric interpolation of the normals. So barycentric gradient of the normals. I also have to interpolate the positions because those are important in the lighting calculation, right? And then I'm going to have to interpolate the colors. If there are different colors on the mesh, if the material is changing, then I need to interpolate that. So let me show you how much better this looks if you do the lighting calculation per pixel after interpolating all these things into the pixel. So here is the result. Here's the difference. And so a few things you notice. Number one, look how much smoother these specular reflections vary as I move around the dyno. And you can see back here on the ellipsoid as well. I don't see, it's not so obvious to me that the vertices are making up this mesh anymore. It actually looks a lot more like a smooth surface. But perhaps the most dramatic effect in this whole thing is actually with, we see some specular, but I would say even the Lambertian effect on the ground is even more pronounced here. Because we actually are doing a lighting calculation using pixel, we're not stuck interpolating these extremely far away vertices from the light. We're actually able to individually compute the lighting calculation at all the pixels underneath the light now. So this is like you can see this is a much more correct model of the lighting. Now, one thing I should point out, this is all physics inspired. This is not exactly the way that specular reflections really work, but it gives us the effect. It's inspired by physics. So this is kind of the best we can do if we're doing real-time rendering with this model. This is called Phong shading. So it gets a little the terminology is a little bit confusing because Phong illumination is the specular part. Phong shading refers to the process of doing the lighting at each pixel in the fragment shader. So you'll find this often. It's like with Euler, right? Euler was very prolific. You have a lot of Euler's theorems. Phong was very prolific in graphics in, I guess, the 70s and 80s. And he did a few things. So one of them was the illumination model that we talked about. But you can do Gouraud shading for that, right? The per vertex. But you can also do Phong shading for Phong illumination. So you do the Phong illumination lighting calculation at each pixel. So what I'm going to have you do in the next exercise is I want you to take all the code that you wrote in the last module, that's in the vertex shader, and basically, the stuff in the main, I want you to copy this into the fragment shader. But in order to get this to work properly, you have to create some varying attributes I shouldn't say varying attributes, I should say some varyings. You need to create some varyings to send over the position, the normal, and the color to the fragment shader, right? So I need to take the position, the normal, color from the vertices and interpolate them over to the fragment shader. And then I have enough information to do the lighting calculation at each pixel. So that's what I'm going to have you do in the next exercise. I gave you some comments to get you set up. I would highly recommend that you actually meet in class and do this together because it's a little bit tricky. But it should be very satisfying when you get it. And we're going to be using similar things in the ray tracer, so this will be really good practice for the last assignment. So I hope you enjoy this, and I hope you find it as cool as I do. And please post any questions on Discord. I'll get back as quickly as I can.